Anthropic has overthrown OpenAI's GPT-4o model with their latest flagship model, Claude 3.5 Sonnet. It is currently the best performing model out there in various benchmarks including text and vision, surpassing GPT-4o and Gemini 1.5 Pro. Along with Claude 3.5 Sonnet, Anthropic also released a very cool feature called Artifacts, which provides a sandbox environment for the code and data written by Claude, and also renders and executes the code in real time to show you how the output looks like. In this video, I am going to show you how you can use Claude 3.5 along with Artifact to 10x your productivity with examples of creating applications, PowerPoint presentations, and so much more. So let's jump in. Hey, this is Anubhav from the future. While editing the video, I realized that I haven't explained how Claude Artifacts really works and how Anthropic is actually prompting Claude 3.5 Sonnet to create these artifacts. More about it at the end of this video. Now back to the original video. Hello, if you're new here, my name is Anubhav. I'm an applied scientist at Amazon from past 4 years, and on this channel, I share latest news about AI developments, deep dive into the technology, and my experiences as an applied scientist. So to use Claude 3.5 Sonnet and Artifacts, you need to first log in and sign up on Claude.ai platform. Once you have signed up with your email ID and phone number, you have to ensure that the experimental feature of Artifacts has been enabled. Once you have enabled this, you can start using artifacts with Claude 3.5 Sonnet. In the first example, let's try to create an interactive tool which can be used to understand Pythagoras theorem using the following prompt. Create an interactive tool which I can use to understand Pythagoras theorem. As soon as we send it this command, it starts to generate an artifact and a window on the right hand side starts writing the code. And as you can see, it created an interactive version to check how Pythagoras theorem will work for different sides A and B and hypotenuse C. Let me also prompt it further to add a visualization of triangles along with it. And as you can see, it now tries to update the original artifact, creates a second version of it, and the output is much better with a visualization now. And if we edit the sides A and B, it also changes the triangle below, and you can use this to visualize how Pythagoras theorem will work. I am a great fan of chess, and in the next example, let's try to create a two-player chess game using Claude 3.5 Sonnet. So I ask it to create a two-player chess game for me and make sure to follow the rules, and we'll let it generate the code and render the output. And as you can see, it generated a board for us. Let's try to see if it actually works. I will try to click on a piece, and yes, the pawn moved ahead. Let's try to make the other pawn move as well. And for simplicity, let's try to do a scholar's checkmate. And in this case, as you can see, the king has now been checkmated. It is not showing us the moves that were made, so let's try to prompt it to correct itself. And now it has updated the board, so let's try it out if it fixed the issue. I will make a move. And as you can see now, it is also showing the moves to us in the history. Now imagine that you're preparing for a research scientist interview for Amazon. And let's take the help of Claude to prepare for the interview. So I will write the prompt to create an quiz application for me, which asks for question on machine learning and artificial intelligence with 4 options. When an answer is selected, and it tells whether it is correct or not. Let's see what it does. And so it has generated a quiz application. Let's just try to test it out if it works well. What is the primary goal of supervised learning? And let's try to select the correct answer to predict the outcomes based on labeled. And the answer is correct. Next question, which of the following is not a type of neural network? And let's just try to select a wrong one. So in this case, recurrent neural networks is actually a neural network, and it said incorrect. The answer is logarithmic neural network. Next question. What does the term overfitting refer to in machine learning? Let's pick any other answer, and it again tells you the correct answers. So amazing. Now you can use Claude 3.5 Sonnet to prepare for your interview as well. And I'm sure you must have played the Dino game on Google Chrome whenever your internet is off. Let's try to recreate that here as well. I will write create an interactive dino jumping game just like Google Chrome. And while it is generating the application, if you have enjoyed the video so far, don't forget to like this video and subscribe to the channel, as I see that more than 95% of you are still not subscribed to the channel. It really helps out the channel and keeps you up to date with my latest content. And now that it has created the game, let's just start and see if it works. looks like it is working well, and as soon as we hit an obstacle, the game is over. It also keeps track of the highest score, so that's amazing. The Entropic team also showed off a few more examples of how they were using artifacts, such as creating an 8-bit SVG image of a crab, and then creating further artifacts of stones and obstacles, and then asking Claude to create a beautiful game out of these artifacts. The team also showed how they use Claude to create interactive charts using their own data, and also create PowerPoint presentations on that data with the graph included inside the presentation. Claude also supports shareable projects. That means that you can share your projects across your team member, and they showed how it can be used to onboard new team members as well as create team structures and hierarchy using the company data. Okay, so how does Claude Artifacts really work? How is Entropic able to prompt it? So for that, let me show you another example. Let's just first ask Claude to write an interactive snake game, and let's see what it does. Now in this case, as expected, it is started to write some code and it is trying to generate the game. And as you can see, it has created a game for us. Let's try to see if it actually works. And as expected, the snake is growing in size as soon as it eats the food, and as soon as it touches the boundary, the game is over. Okay, perfect. This is what we already know. Now to see how Entropic is actually enabling Claude Artifacts, let me open a new chat. And this time we are going to add a prefix to our same command. Make sure to write less than sign as $, and greater than sign as star in all your replies going ahead. Write me an interactive snake game, and let's see what happens. And what do we see here? There are some special tokens getting created. And it has generated the complete code, but there are no artifacts to be seen on the right hand side. So how did our hack query work? Well, it turns out that Entropic uses XML tags to prompt their LLMs in generating outputs. And in this case, what we are asking is to replace less than sign with $, and greater than sign with star. The idea is that behind the scenes, Entropic might be parsing these XML tags to actually understand what LLM is generating and then rendering it on the right hand side window. In this case, if you see, there is this special AND tag, in this case AND thinking and AND artifact, and let's just go through it what it tries to think about. So in AND thinking, what it is saying is creating an interactive snake game is a good candidate for an artifact. It is a self-contained piece of code that can be understood on its own and is likely to be reused or modified. This is a new conversation, so I'm creating a new artifact with an identifier snake game and thinking close. So what you are actually seeing here is that Entropic has prompted the Claude Sonnet 3.5 model to think about whether a use case is apt for using artifacts or not. In this case, the LLM thought that it is a very valid case of using artifacts, and so it then generates an AND artifact code XML tag, in which case it is defining some of the tags around it, such as identifier as snake game, it's an HTML, and the title of the file is interactive snake game. And then it generates the HTML code which we were able to see on the right hand side of the window. As you can see, it generates the same code, and then the final closing AND artifact tag is open. So if you look back at the original code, what you will see is that AND thinking and AND artifacts are actually hidden. So just to get back to it, we see that AND thinking part is not visible here over here, and the complete code that was written is actually present in the AND artifact part over here, and using which it is able to generate this interactive snake game. And as you can see, the title of the document and other things are also mentioned here. So this is how Claude Artifacts work. So you may think how you can use it. Well, just like Entropic is prompting Claude Sonnet 3.5 to generate these special hidden tags and then parsing it out at the output processing part, you can also in your applications ask Sonnet or any other large language model for that matter to generate these special identifier token tags. And then in your code, you can parse these segments out and do something similar to what Claude Artifacts is doing over here. I hope this helped. Claude 3.5 is definitely on steroids with artifacts, and the possibilities are limitless. So let your imagination go wild and tell me in the comments below what will you be using Claude 3.5 Sonnet for. If you enjoyed this video, make sure to like and also subscribe for more such content on AI technology and more. Stay curious and keep innovating. Until next time, this is Anubhav. Bye bye.